Hey guys, so I am shooting this video for Monday's notes. This is about the product rule and the quotient rule. But before we get there, I'm going to do a quick review of things we've been doing since the last test that you had. So let's look at this. Is f differentiable at x equals 2? Do you remember that I said to you, differentiable means are you able to ride that roller coaster? So two of the things that need to happen: the tracks need to be connected, the function needs to be continuous, and the slopes need to be smooth. Remember what we talked about in class. It doesn't matter the order you show that in. If one of those things fails, the function is not differentiable. I'm going to show both of them, and then I'm going to show you maybe a shortcut. So let's do continuity first. We have the limit from the left, which is the less than. So I'm going to plug it into 4x squared minus 2, and I get 2 squared, which is 4. 4 times 4, which is 16. 16 minus 2, which is 14. And I'm going to do the limit from the right, which is the x cubed plus 6. So 2 cubed is 8. 8 plus 6 equals 14. So the limit exists. And then the equal sign is right there. So f of 2 is also 14. You don't need to show the calculation again. So we know that this function is continuous at x equals 2 because the limit from the, just the limit exists, the point exists, and they equal each other. So a nice little review of continuity, and that's why I wanted to show it, because remember, whenever it says use the definition of continuity or is this function continuous, we always have to ask, is the limit from the left and right and the point all equal to each other? So it is. So then let's look at differentiable. Now, differentiable are the slopes from the left and the right, are the derivatives from the left and the right. So let's take the derivative of this less than sign, 4x squared minus 2. The derivative of 4x squared using the power rule is 8x to the first. The derivative of negative 2 is 0. Remember, the derivative of any number is 0. So when we plug in 2, we get 16. The limit from the right is going to go into the derivative of x cubed plus 6. So the derivative of x cubed is 3x squared. And the derivative of 6 is 0. So we are able to just do the derivative as 0. And we plug this in, we get 2 squared is 4. 4 times 3 is 12. Aha! So we have slopes that are not the same on both the right and the left. What that means is we have like a roller coaster that's going up, and then we have a roller coaster doing this all of a sudden. It didn't ease into it. It just went from 16 to 12. It formed a corner. So we can't have derivatives of that corner. So we would say f is not differentiable at x equals 2 because the limit of the derivative from the left did not equal the limit of the derivative from the right. And this is how the notation is going to look. Now, we talked about this in class. I did something, if you're color sensitive, then you'll be able to see my my two colors. On the left-hand side, I did continuity in black. On the right-hand side, I did differentiability in red. It does not matter which one you started with. And if all you showed was red, then you still have full credit, because as long as one of them fails, that's good enough to say not differentiable. However, if the answer was yes, it was differentiable, you have to show both black and red. It doesn't matter what order you show them in, you just have to show them both. Okay, so that being said, let's move to the second. We did graphical. F is not differentiable. So again, it's basically saying, where is F not differentiable? Choose all 6 that apply. On which roller coasters are you going to die? You are definitely going to die on this one. You're definitely going to die on this one. You're definitely going to pass away here. You're definitely going to fall apart there. You're definitely going to fall apart there. And that's 5. So you might be going, well, this one's safe. That looks like things I've written. And this one's like your garden variety roller coaster. That's safe. It's this guy right here, because I want to remind you, when we do this, what did you learn in Algebra 1? Positive slope, negative slope, horizontal slope, undefined slope. A derivative is a slope. So when you're going straight up and down, that is undefined. So this is not able to find a value of the derivative because it is undefined. So we have 6 examples right there. So that was the graphical example. And you'll notice on the top row, all of these are continuous but not differentiable. On the bottom, they are neither continuous nor differentiable, or neither. If you're not continuous, then you are surely not differentiable. If those tracks aren't connected, you are certainly not a safe roller coaster. Okay, then we bounce back a couple days and it says find the equation of the tangent line, which we've been doing from the start, and it says when x equals 2. Well, remember, equation of the tangent line, when we hear the word tangent line, we should be thinking derivative. And what do we need for an equation of a line? Well, first we need an x value, then we need a y value. So let's get that y value, 2 cubed minus 2 squared plus 5 times 2 minus 1. So we get 8 minus 4 plus 10 minus 1. So we get 4 plus 10 minus 1, or 14 minus 1, or 13. So now we have our x value, and we have our y value, and we need a slope. Well, what is another word for slope of the tangent line? Slope of the tangent line is 5 words. That means one word that begins with D, and that is derivative. And now you know how to use the power rule. So let's use the power rule. Multiply the exponent, subtract 1 from the exponent. Multiply the exponent, subtract 1 from the exponent. Remember the shortcut for any number that it's x to the first, the derivative just ends up becoming the number that's in front, the coefficient. Because right now it's 5x to the first, so 1 times 5 is 5, becomes x to the 0. You don't need to write x to the 0. And then any derivative of a number is 0. So the derivative of a constant is always 0, because the slope of a constant is 0. All right, we plug in 2, we get our answer. So 2 squared minus 2 times 2 plus 5. So we are doing 12 minus 4 plus 5, or we are doing 8 plus 5. And we also get 13. Wow, that's kind of shocking. Okay, wasn't meant to be that way, but so be it. Okay, so we get y minus the y coordinate equals the slope of the tangent line times x minus the x coordinate, and there you go. So combining power rule and the concept of equation of the tangent line. By the way, what is it telling you when it has a slope of 13? That means for the function f at x equals 2, the graph is going up, and it's going up pretty steep by a slope of 13. Okay, then let's take back another step. It says match the graph on the left with the match on the right. I'm going to cross this out because this is, I'll fix it for our notes, but it says match the original graph on the left with its derivative graph on the right. Okay, so I want to remind you, if this is the original and I'm trying to match it with its derivative, then a good way to do that is to just figure out, okay, at this, let's pretend this is 1. So at x equals 1, the slope is 0. So I am trying to find a graph that at x equals 1, the y value is 0, because the slope value on the original graph becomes the y value on the derivative graph. If I picked something right here, I'd be like, okay, at 0, it looks like the slope is -2. And at, I don't know, 3, it looks like the slope is +2. So I'm looking for a graph that at 0, the y value is -2, but at 3, the value is +2. So that's going to be letter C. We also learned that because of the power rule, a quadratic to the second power would result in a derivative to the first power, which is a line. Okay, let's look at letter G. I'm going to do the table over here. We have x and we have y prime. So at x equals 0, it looks like the slope is 1. Let's call that 1. At x equals 1, the slope is 0. Let's call this 2. At 2, the slope is -1. Let's call this 3. At 3, the slope is 0. So I am looking for a graph over here where it goes 0, 1 to 1, 0 to 2, -1 to 3, 0. There's my graph straight across. A trig function becomes another trig function. Okay, and then for letter the number 3, same thing. I'm going to go here. I'm going to do it off to the right. I'm going to go x and y prime. At 0, it looks like the slope is like 1/2 maybe. Okay, and I'm just guesstimating. I mean, it's not an exact science. I'm just guesstimating. Okay, you could even say that the slope is maybe 0 because it's like flattening out. See how it's like kind of turning a little bit there, whatever you are trying to do. Then you're like, okay, at 1, the slope is maybe 1. And at -1, the slope is also 1. Okay, so I'm looking for a graph that is always above the x-axis and that it's doing certain things. So we have A. And again, this is a cube function. Remember, a cube from the third power. So then when I take the derivative, that's to the second power. So basically a cube graph goes into a quadratic graph. And you might be saying, you said 0 is 1/2 and over here is 0 is 0. Well, we talked about how this might be flattening a little bit. Again, it's just a guesstimation. You're just trying to match it accordingly. Last one, before we do our new material, again, we're just kind of doing what we've done so far in reverse order of how we've learned it, which is kind of an interesting way of doing it. I have lost the ability of where my mouse is. There we go. All right, so the following notation means the exact same thing. What information are you being told? Well, this is the definition of the derivative at x equals 10. This is the alternate definition of the derivative at x equals 10. So what is another word for derivative? Slope of the tangent line. So we are being basically, these all mean the same thing, which is f prime 10 equals 7. Just really long ways of saying the same thing. And that is basically saying the slope at x equals 10 for the function f is 7. So, and what is that telling me about the direction of the original graph? The slope at x equals 10 for the function is 7. So that means at x equals 10, my graph is going up. Okay, so that kind of encapsulated everything we've learned in the last week. So let's see what we're learning new today. We are learning what's called the product rule. And I want to remind you that in math, a product is the multiplication of two things. So you want to look for the word times. When I do this in class, I make everybody read it out. F times g of x. And when that is the case, the derivative rule is the following. Take the derivative of the first function, leave the second function the same, plus leave the first function the same, and take the derivative of the second function. So you're basically derivative of one, leave the other the same, plus sign, and then just do the reverse. Sometimes you're going to see in textbooks or on online help, u and v. So the derivative of y, when it's u times v, did you hear me say times? U times v, that's a hey, I need to use the product rule. And the product rule is take the derivative of the first function, leave the second function the same, plus the reverse of that. Okay, so let's see what it looks like in action. Okay, so I'm going to do an example. Okay, so we have 3x minus 2x cubed times 5 plus 4x. Oh, there are two different functions here. So the derivative h prime x is take the derivative of the first function. So we have the derivative of 3x is 3 minus 6x squared. Leave the second function exactly the same. And then put what kind of sign? The product rule gets a plus sign. Take the derivative of the second function only. So we're going to leave the first function the same. And we are going to take the derivative of the second function. And the derivative of the second function, what is the derivative of 5? 0. What's the derivative of 4x? 4. We can leave it like this, and I am going to leave it like this for the purpose of your notes. We do not need to multiply that out. So we're just going to leave it unsimplified for the purposes of notes. Okay, let's look at this other one. All right, I have a function here and a second function right here. So let's do the derivative rule. The derivative rule says take the derivative of the first function, which will be 10, leave the second function the same. The product rule gets a plus sign, and then we do the exact opposite. Keep the first function the same, take the derivative of the second function. Remember, anything x to the first becomes the number in front, and anything that's just a number becomes 1. This one's a little bit easier to go ahead and multiply out, so let's just go ahead and do that. We get 10x minus 40, and we get 10x plus 2, and if we combine this together, we get 20x minus 38. Pretty good. Now, you might be going, Well, you know, when we were doing derivatives before, could I have just multiplied this out and gotten and FOILed it and gotten 10x squared minus 40x plus 2x minus 8, and then gotten 10x squared is minus 38x, and then use the power rule to take the derivative and get 20x minus 38? Why, yes, you can. So again, sometimes learning different methods helps us solve a problem, but it also starts to complicate things in our head because then we always think we need to use that method. And the answer is sometimes you can just rewrite and have an easier way of doing something. So the product rule means take the derivative of one, leave the others the same, plus sign, reverse it. So what if there was 3 functions? Well, you just keep doing that pattern again. Okay, so now we have 3 functions. We have this red function, we have this blue function, we have this green function. X squared times x plus 2 times 3x to the 4th plus 5. So we're just going to write, okay, well, with that being said, I'm going to take the derivative of the first function, 2x. Leave the blue the same, leave the green the same. What kind of sign goes in the middle for the product rule? A plus sign. And then this time around, we are going to leave the first function the same. We are going to leave the third function the same. And we're going to take the derivative of the second function. What is the derivative of 1x? 1. What is the derivative of 2? 0. And we're done. Third time around, we're going to leave the first function the same. We are going to leave the second function the same. We're going to take the derivative of the third function. So 12x cubed plus 0, and I'm not going to write the plus 0. And I'm just going to leave it like this. Totally fine to leave it unsimplified, because if it said find y prime at 2, I find the derivative, and then I just start plugging in 2. No need to simplify. You can just leave it like this long stretch. But again, the product rule, you recognize when you start reading it out loud, the quantity of something times the quantity of something else. Oh, you said the word times. So then I need to use that separation where it's derivative of 1, keep the other the same, plus reverse it. Okay? So when we talk about multiplying, we also seem to talk about dividing. So we have to talk about the quotient rule as well. Now, the quotient rule kind of starts the same as the product rule. We have f divided by g. So we're going to leave g the same. We're going to take the derivative of f, except this time around, we're going to subtract them. Then we're going to do the opposite. We're going to leave f as is. We're going to do g prime x. And then we're going to do the original denominator squared. Okay, so I'm going to give you a mnemonic in a second, but first I'm going to give you the notation. All right, so let's look at this again. If it's written like this, we say y prime. We go denominator, and then take the derivative of the numerator, vu prime, minus, keep the numerator the same, take the derivative of the denominator, v prime, all over the original denominator squared. Now, you're going to hear this on a lot of calculus videos. You're going to hear it from me every time we do product rule and quotient rule, but especially quotient rule. Here is quotient rule. Low, d high. It means take the denominator, just write it, times the derivative of the numerator, minus high, d low. Okay, so we're basically doing low d high minus high d low all over low squared. Some people like to say low low. So low d high minus high d low all over low squared, or low d high minus high d low all over low low. Okay, low d high, which means we'll keep the low, we'll keep the denominator the same, times the derivative of the numerator. Low d high minus, keep the numerator the same and multiply by the derivative of the denominator, high d low. And then take the original denominator and square it. Low low, or low squared. Low d high minus high d low all over low squared. Low d high minus high d low all over low low. Doesn't matter how you do it. Okay, so I'm going to do that every time I do this. Oh, I have 5 divided by x plus 3, and I'm being told take the derivative of that. All right, so low d high, the derivative of the numerator, minus high d low, the derivative of the denominator, which is just 1, because the derivative of 1x is 1. The derivative of any number is 0, all over the original denominator squared. Now, a little bit of a trick here for you. Always simplify the numerator. Don't worry about the denominator. Just leave the denominator like that, okay? But x plus 3 times 0, that's just 0 minus 5, and leave the denominator the same. We are going to be using these in the next unit a lot, so we want to leave them in factored form as much as possible. So don't ever multiply out the numerator. I'm going to the denominator. Don't multiply the denominator. Okay, don't multiply out, which is also called distribute. Don't distribute the denominator. Just leave it as is. It will always be easier for you to do that. So don't distribute the denominator. Okay. One more to go, and then I'm going to just show you one little extra thing. Okay. So here's my denominator right here, and here is my numerator right here. Oh, I just realized I didn't color code the last one. So here we go. Low, keep it the same, d high, minus this time, high, keep it the same, d low, derivative of the denominator, all over the original denominator squared. Remember, do not distribute the denominator. Usually you can leave this unsimplified for the purposes of your notes. I'm going to just take it one step farther and actually do the multiplication and simplification just so you can see it being done. But do you notice that I'm multiplying and multiplying first and leaving them in parentheses? So I did multiply, and then I will subtract. So I'm doing that at once. I multiplied these guys, left it in parentheses, multiplied these guys, left it in parentheses. So now I have 12x squared minus 24x squared, which is negative 12x squared. I have 3 minus 16x. Those aren't like terms, so minus a negative 16x, and then the plus 3. And there is our final answer, because I do not believe that's factorable at the top. Okay, so there you go right there. Again, low d high minus high d low, all over low squared. Similar to the product rule, I do want to show you one other little thing. If I had a function that looked like this, 1 over x cubed, we just learned the product rule and the quotient rule. So your brain might be going, oh, this is a quotient, this is a fraction. So I have to do low d high minus high d low all over low squared. Then you think, oh, I might have to simplify. So I get negative 3 over x squared. Now, x cubed times x cubed times x cubed is x to the x cubed times x cubed is x to the 6th. So in this case, because you're not distributing like a whole lot of things, it's easier to just leave it simplified. And then we can see we get negative 3x to the 4th. So we did this whole thing using quotient rule. Totally fine. But remember that we just got out of the unit of power rule. And we learned in power rule, you can't have an x in the denominator. So what if I rewrote this as 1x to the negative 3rd and then told you take the derivative? Well, you do negative 3x to 1 less on the power, and you have your answer. So this is an example of I could do the power rule or I could do the quotient rule. It's up to me. I have multiple ways of doing the same problem. Now, some people, they go, if I see a fraction, I'm just going to use quotient rule every time. Totally fine. Just giving you an option. And that's the end of our beautiful notes right there. I hope that you got a little bit of a review of what we were doing before and then a little bit of extra now. I do have to tell you, tonight's homework, as you know, is to add to your notes for e to the x, ln x, sine x, and cosine x. And then we're going to practice everything tomorrow so that you can intersperse these type things. Okay, so keep that in mind, and you guys have a good rest of your